And then you have that connected to the back and everything. I think it's ready then.
Everything is yeah, connected. The enclosure is not completely,
That's okay.
you can probably do that later. Yeah.
Yeah.
So you have the screws for that.
Remember, make sure to open the platinum valve.
Oh yeah, you're right. I should not
On the
forget
bottom.
that. Yeah, the platinum valve is open now.
Yep. And then we are going to, since this is just like a test, a deposition like test, like film test, I would just stick in a bare wafer for this test.
Yeah.
You can vent the system.
Okay, let me vent the system.
And then stick in the substrate that you want to test out.
You said we are just doing a quick test and then we'll put the actual wafer. Is that what you said?
Well, it depends because for the film test, if you want to confirm you've actually deposited platinum, platinum has a pretty low growth rate, so the test might it might take a couple hours.
I see.
Yeah, depending on how thick you were.
Got it. Got it.
Yeah.
Okay.
Because I think if we do 100 cycles, that might be around 4 nanometers, maybe.
Okay, so that's in. Let me pump.
We can pump it down.
Okay. And then,
And then
how do I make sure that the ozone system is working?
you'll know the ozone system is working if during the ozone pulse, the pressure spike is really, really high. So it will usually be in the orders of 1,000 to 2,000 millitorr.
Okay.
When the ozone pulsing, I think.
So how do I know it's
it's a
ozone
really
and
big
not
spike.
oxygen coming in to the system?
What?
How do I know that it's ozone and not oxygen coming into the system?
You'll know I don't know if there's a actual way to test when it's happening.
Uh-huh.
But if it says if you have the output connected to the correct thing and the power output of the ozone generator
Okay.
is 100, then you know it's producing ozone.
Okay. Okay.
Yeah.
Okay, so the wafer is in.
The wafer is in, and I don't know if you remember what I said about if you're running any recipe that's at a higher temp, or if you're heating your precursor source, then you should set the pre-process purge time to a higher time so those temperatures can stabilize longer.
No, I don't remember this. Can you repeat that? Sorry.
Since we just turned on the platinum precursor bottle heater, I would suggest increasing the pre-process purge time.
Pre-process purge time.
So you go into the setup. The default is 10 minutes, but if you're using a heated source and you just turned it on, then I would increase that time. So you can go into the setup page.
Oh, okay.
And then under 10 minutes, it can be like 15 or 20 minutes. It's the top field.
Oh, pre-process purge time.
Yeah.
Okay, so we are doing this for platinum because it has a heated source, because it's a heated source.
Yeah. And since we just turned on the heated source within this allotted time, it's always good to set the pre-process purge time to a little bit longer.
Okay, so
15 or 20 minutes should be fine.
So let's do 15 for now. Is that okay?
Okay. And then
so let's go over this one at a time.
Yes.
The pre-process purge time, that's before the process is started. Once we run the system, once we run the cycle, before the actual thing even starts, that's the process, the purge time. It's purging the platinum line, is that right? In the chamber?
Yeah.
Okay.
So it's just making sure all the temperatures are stabilized and that the chamber's nice and purged for when you loaded your sample in.
Okay. And then dose fill time. So what would that what is that parameter?
So the dose fill time, how in the main diagram there's the dots on the left and the dots on the right?
Right. These ones, right?
Yeah. So
okay.
The dots on the left, so 5, 6, and 7.
V1 through V4?
Those are your dose lines. The ones in the red little box. Dose lines?
Oh, left. Okay. V5 through V7. Okay.
Yes. So the dose valve fill time, it will pulse into it for 1 second, and it will stay in that line. And then you'll see in the setup page, it says, I think, dose valve open or close time. Oh yeah, delay. So then it delays like 650 milliseconds, and then it opens again into the ALD valve.
Hmm.
And that will be valves 1 through 4.
That's a chamber standby temperature, purge flow during exposure.
Yep.
Dose valve close delay, okay. UF. What is UF valve pulse time?
I believe that is just the what's it stand for? Do you guys have the manual? It might be in the manual. I don't
Okay.
remember off the top of my head.
Okay. And that's 550 milliseconds, yeah?
Yep.
Okay. Chamber standby temperature.
Yep.
Purge flow during exposure.
Yep.
So what is this purge flow during exposure?
So this will actually be utilized during this platinum run because in our platinum recipe we have expo, which just means for that 1 second that we set it to, it's trapping the platinum precursor
Right.
in the chamber
Uh-huh.
and allowing it to have more time in the chamber with the substrate.
Right.
Yeah. So during that time, the flow of the nitrogen will be 10 skip.
Oh, during that time, during the exposure 10
During that 1 second.
And it's flowing nitrogen over that.
Correct.
Nitrogen over that for 1 second.
Yes.
I see.
And then it will go back to whatever it was before.
Got it. Okay. So this happens only for this happens only when we are using that what is it called?
Expo. Yeah.
Okay.
So for example, for the TMA recipe that we did before, it wasn't using this.
Right.
there
For
wasn't-
TMA, yeah, you're right. Okay. Pre-process purge time, dose time, fill time. Okay.
Yep.
All right.
Okay, samples in. You open the precursor bottle. Right?
This is already opened. Yeah, the precursor bottle is already opened.
I think we're ready.
Okay, so just go to the custom recipe again.
Custom screen. Yep. 100
And
cycles, yeah. And remember, you need to set the file name every time you want to run something.
set the file name.
Yeah.
So the heater is still on. Yeah. Platinum. What parameters? What do you think we should name it as for platinum?
Platinum plus O3. And then the deposition temperature of 250. Usually I like to say the reactant because, for example, with TMA, you could run a TMA process, but then since you can run TMA with both water and ozone, it's good to know which one you actually used.
Oh, okay, so in this case it's okay. So platinum with ozone 250C.
Yep.
Okay.
Yep, that should be good.
Okay, enter.
Yep, and then you'll see back. And then now you'll see that the field is able to click, so you just click Run Custom 2.
Run Custom 2, okay.
And then we can go to the main screen.
Get this process
and
running.
you can see it's already counting down the pre-process purge on the bottom in the
Right.
cycle status window. Yep. And so for this process, platinum is definitely a longer process because the purge times just need to be a lot longer. So for 100 cycles, it will be 2 hours. 18
Oh.
minutes. Yeah.
Okay.
But it sounds like you guys are going to be running thinner stuff, so hopefully your processes won't have to be so long.
So what is the thickness we expect for this film for 100 cycles? Platinum.
Probably below 5 nanometers.
Oh, wow.
Platinum's pretty slow.
Yeah, and these are continuous films? These are not islands or nanoparticles?
Yeah, it should be continuous.
Oh, wow.
Just keep in mind also if you're running lower temperature processes that your purge times are going to have to be a lot longer.
Oh, okay.
Yeah.
But lower temperature, the purge times have to be a lot longer.
Yeah.
So
No
there's a,
matter what material you're running.
okay.
Because at lower temperatures, it likes to like sit in the chamber a lot more. So you want to
Okay.
make sure it's not depositing on the walls of the chamber. So
Mm-hmm.
yep. You have any
So
other questions?
I think that's good. So now we need to make sure that the ozone system is working, right?
Yep.
Okay.
Everything looked good though. You reconnected it. The pressure was going. The power was on.
Uh-huh.
Look good.
Okay. Okay. So should we monitor the pressure curves? Did the process start, or it's just
No, there's
pre-venting?
still 11 minutes left.
Oh, still 11 minutes for the pre-purge, right?
Yep.
That's the
So once
pre-purge.
that's done, then we'll see the pressure changing.
Okay. Okay.
Yeah.
Now you can use ozone for Al2O3 deposition as well, right? If you need it, if you want to.
Yeah. Yep.
You don't have to use water there. You can still use ozone there.
You
Oh,
can use either, yeah.
I see. Can we have a recipe for that as well? Can you send me the recipe
Yeah,
for that?
TMA, at low temperatures, ozone actually works better, I believe.
Yeah, so that will be great if you can have that recipe for that we can.
Yeah.
So let's
Let
go to the
me,
custom recipe once. Let's see if. Oh no, this one not. It's not this one. Load recipe, right? Okay. So that's platinum 250. DD
yeah.
close. Dose
So we can
valve
scroll
fill,
down.
right? That's 1 second. 650 milliseconds. That's fine. Exposure A.
Yep.
And but here we are not specifying any pre-purge, right? Pre-purge time on this screen.
Correct. The pre-purge is always the default setting in the setup screen.
Oh, okay.
Yeah. So like anything in the setup screen that you have, that's always default for any process you run.
Okay, that's default for every process. So that means when I come back for AL2O3 deposition, I can either keep it at 15 minutes, shouldn't harm, or I can reduce it to 10 minutes.
Yeah.
Right?
Yep.
So maybe we can just to be on the safe side, just have it 15 minutes for every precursor. That should be fine,
Yeah.
right?
Yeah.
So we don't have to worry about.
If you're trying to play things safe, it doesn't harm to have the pre-process purge longer.
Right. And what are
Like
the
if
other
you're in
things?
no rush, then it's fine.
What are the other things in the setup screen that are specific to recipes? Let's see.
If you're running a lot of recipes, so you said you want to run low temp recipes, right?
Right.
So once you start getting the processes like more refined for those low temperatures, you're gonna want to change the see the chamber standby temperature.
Uh-huh.
So if you're running like multiple things a day at like, let's say 100, then you would probably want to set that to like 90.
Okay. What is the chamber standby temperature?
140, but you're running lower, it can take a lot longer to cool down the chamber than it takes for it to heat up.
Okay. Okay.
Yeah.
So can you speak a few words about the chamber standby temperature? What does that mean here?
So that means that for example, when this platinum process is done, even though the deposition temperature is 250, like the chamber temperature,
right?
After it's done, the standby temperature will idle
Got
at
it.
140.
It basically goes down to 140 degrees Celsius, stays
but
there.
You can set it to whatever. So usually you want to set it to slightly lower than like what you're running at.
Okay, understood.
Yeah.
Understood. Okay.
So then when you go to run something again, you don't have to wait for it to heat all the way back up or wait for it to cool all the way back down.
Right.
Yeah. So for your low temp stuff, you'll adjust that temperature to
exactly.
whatever you think is necessary. Yeah.
Okay, so that's the only thing that we changed for the platinum, nothing else, right?
Okay. Yep, all the other things you should keep the same.
Should be pretty strong. Okay, so maybe you can not mess with this too much.
Yeah.
So that's good.
I don't touch that page.
Yeah. So the setup screen is fixed now. And we still have 7 minutes for the pre-purge of the limes. And we are purging the. So why am I not seeing in this screen on the right the purging or it?
So the pre-process purge is purging right now, which just means you're just flowing the nitrogen through the chamber.
I see.
So it's flowing the 25 skim nitrogen through the chamber.
Okay.
Just for like 15 minutes, and that's
Okay.
what it's doing.
I see.
Right, like hafnium, but we
need to see if with 5 nanometer, have you measured the conductivity of these films?
My coworker has, I believe. I have not personally.
Okay. For high aspect ratio structures, you suggested that we do go for the exposure,
Yeah.
higher exposure. Okay.
When this process is running, can we check other recipes, or does this system allow to check the
Yeah,
recipe?
you can do that.
You can go wherever. Oh, it's starting. It's
No,
starting.
not
You can see it.
load recipe.
Okay, now it started.
Custom.
So you can see. So
Okay,
right now it's pulsing the
now.
platinum.
Okay.
You can see
Yep.
that. And then
It's purging.
okay, it's purging. Okay. Yeah, we should be able to see the curves now. Yeah, the pressure curves.
Oh, okay.
Now the ozone should be on.
Yeah, the ozone pulse should be very large.
Okay. So should we monitor the pressure curves, you mean? You think?
You
can see that ozone.
Oh yeah, yeah. See when the ozone pulse it went to like I think like around 3,000
Oh.
millitorr? Yeah.
So that's the ozone. Okay.
Yep.
I see.
So it looks good.
Okay. Yeah.
Okay.
Does it show? Okay. Does it tell that like what I'm looking over here, what pressure I'm looking over
Yeah.
here?
Millitorr.
No,
That's
no, no, millitorr, but like material, like what?
Uh,
Because
this-
you know it's ozone,
for
right?
this,
If
it's
somebody
pretty-
like come from outside and see over here, can tell like.
So now we are
So that we have to see in the log, right?
Like you want to know which peaks are the ozone or the metal?
Yeah.
So usually it's you can go to the main screen, and when the metal's pulsing, you can like look at what the pressure is, and then same with the ozone, you can like look at what the pressure is.
So now
so
it's
then when
purging
you
it.
look at the graph,
So
Which is
figure out which
purging.
one's which.
It's only pumping right now. So ideally it should be platinum and TMA, right?
So
Okay,
now-
yeah, now it is doing something. Now it's purging ozone, right?
it's sending in the ozone. Yeah.
Yep. And so since the ozone spike was so large, you know, the larger spikes on the pressure curve
Uh-huh.
are the ozone.
Okay.
It can definitely get trickier when your two precursors have like similar pulses. Yeah. But then if like you're pulsing them for a different amount of times, like you're pulsing it 4 times versus 2 times, like obviously whichever one has the 4 pulse, is like corresponds with that one.
Okay.
Yeah.
Okay,
So another thing we could do is, because platinum is so thin, maybe we can do the EDS on the sample that we deposited to see if you're getting platinum peaks, right?
Again.
Okay.
If sometime like from the recipe, if we want to get the data or data of the pressure curve, thermal curve, does it allow to?
So do we have a log of the?
Export any data?
Can we save the log, or can we access
Yeah,
the?
you should be able to. If you go into the pressure curve screen.
Oh, file transfer.
believe,
File and
yeah,
how it transfer the
you can
file
either transfer the
to the
file
pen
or I
drive
think
or
like one of the settings on the side on the right.
History log.
That
what are
allows you to
these
look at like
symbols?
the different ones within the
This
system.
a camera.
What is this
First
one?
one is
That looks
camera.
state.
Second
Oh,
one,
that says this.
yeah. The
Yeah,
second and
click on
third
this.
one, I'm not sure what those ones are. But
What
I
is the
think
camera one? What does the camera do?
I think that just takes a screenshot of like, for
Oh,
example,
okay.
like what you're seeing now.
I see.
I don't know where it saves it to.
But export is not possible, right?
Well, we'll see.
It may
File
be
transfer.
possible only through Bluetooth or something, because I don't see any pen drive option over here, right?
I believe there's, oh, where is it?
Do you see any pen drive? USB.
Nope.
I feel like you should be able to do it through the USB on the back, maybe.
USB on the back.
The USB on the back is how we upgrade the software on the system. So I assume you could also
Okay.
then get onto that onto the computer.
So is that pen drive we can save the data, right? Save the log.
No, that USB has the operating system. You said.
Yeah.
Yeah,
Or you
Austin.
can connect through Ethernet.
Oh, okay.
I see one USB as well on the back side. So giving the USB, it's to save the files or mainly the software update.
Mainly we use it for the software update if there's anything we need to update.
Okay. No any file
Yeah.
saving or file export or something.
You could do it through Ethernet, but I think you should be able to do it through the USB too. Because if you can get software onto the system through the USB, I assume you could do it the other way.
So maybe you can say a few words about the multi-layer films.
Yeah.
So if I
So
want
if
to
you
deposit.
want to do a multi-layer of like different metals or different metal oxides, you can set it up through the multi-layer screen.
Okay, so let's see multi-layer, just to see what
And
that
so the
looks.
multi-layer screen, for example, you have position, meaning like 1, 2, and 3, meaning the first thing it will run will be like, let's say it will run like aluminum oxide layer.
Okay.
And then the next layer would be like hafnium oxide, for example.
Uh-huh.
And then you could alternate those layers based on like the ratio of thicknesses you want for those two materials. And then so the next column, recipe number, that number pulls this recipe from your load recipe screen.
From the update recipe names, you mean?
Yeah.
Let's see what you get.
Yeah.
Oh,
So for example, recipe 1 is TMA, or recipe 0 is TMA1.
how do I edit
So
that?
if you change the recipe, you have to change it through the recipe number. So for position 2, if you type in like the recipe number, type in 2.
R2, okay.
And then okay, and then update recipe names.
Oh, okay.
Now that's the platinum layer.
So you have
And then
TMA.
you can set the number. Yeah.
Okay.
Yeah.
So that's hafnium oxide. Okay. It's TMA or
Yep.
platinum hafnium oxide. Number of cycles per sublayer.
Yep. That's just gonna be like whatever you decide is the best ratio of each layer for the recipe.
Okay. So that means the number of the thickness, right? Because that determines the thickness of the each layer.
So the number of subcycles will be like, so if you have one subcycle of TMA and one subcycle of the platinum, and you have 10 total cycles, that'd be 20.
Okay.
One of that and one of that. Does that make sense?
So why do we have precursor A and precursor B again here?
Because the load recipe, it doesn't actually, in the load recipe, you've like named the file the material, but you're not actually telling the machine what line your precursor is on. So precursor A and precursor B is always set up for like what you have put on your system. So for example, TMA is listed first because that's on line 1. Platinum is listed second because that's on line 2.
So I need to basically
Does that make
select that as TMA. Okay,
Yeah.
let's say this is
You
half
can
name,
increase number of layers as well, right?
and that should be platinum.
Yep.
What you have
And
to
precursor
do
B is no, this is ozone.
Yep.
Ozone and
Yep.
H2O. Because I was thinking that when we load this, if I go back here, don't we have that in this recipe? Don't we have that information?
No. So you're creating the recipe, but you see on the bottom of the screen for this page, it says precursor A and precursor B. You still have to tell the system like which line the precursor is on.
Oh,
So for
okay.
example, the reason why it says platinum there is because in the setup page for precursor like 2, you set it up to be platinum
Okay. Setup
in the
page.
setup page.
That's platinum. Okay. Hafnium. 4 is
That's
H2O.
why, so like that's why in the multi-layer screen when you saw the drop down menu, it was like TMA, platinum, and then hafnium, because
Right.
like that's like precursor 1, 2, 3.
Got it.
If you were to like put TMA on line 3, then it would be like the last one on the list.
I see.
Yeah,
I think
so it's like telling the machine like which line your precursor is on.
Got it.
Yeah.
Okay.
So always make sure your precursors match up with like the recipe.
Right.
Because you could say platinum recipe, but then if you select the wrong precursor, it will tell you
Right.
whatever that is.
Right.
Yeah.
Okay, so in the custom recipe, we specify that on the, okay, right here. Precursor A and precursor B on here.
Yep.
And then the load recipe, when we have to actually run a process, then you select that. Let's see. Nope, you're not able to select it.
You don't select it, you just input the fields on the bottom.
Okay, here and then.
Like you tell it what recipe, and you tell it what precursor.
Number of cycles, recipe number 1, number of cycles, and then, okay, precursor A, precursor, you specify that over here, and then you run it.
Yep.
Okay. I see. So if I want to make, let's say, a 10 nanometer TMA film, followed by a 5 nanometer platinum, followed by, let's say, 10 nanometer hafnium oxide, then for TMA, I need to have this set at 100 cycles, right?
100, yeah.
Yep.
And then platinum maybe 100, because again, that gives us 5 nanometers.
Yeah.
And hafnium oxide maybe 100.
Okay.
Yeah.
And then if I want to repeat the whole stack, then I can do 2, for example.
Or 2 or like 10.
So you have 3, and then you're repeating that. Okay.
Yep.
And then precursor A, precursor B, and then you can specify the recipe number here.
Okay.
For each of these.
Advantage.
If I don't want, let's say, hafnium oxide, then what do I do? If I don't want to.
If you don't want hafnium oxide, then you just put the number of cycles in the sublayer as 0.
Oh, okay.
Yeah.
Yep.
The shutdown procedure. Once everything, can you go over very quickly the shutdown procedure?
Remind me again how often you like you're planning on using the machine.
Okay.
Like, are you planning on using it like every day, like once a week?
Once a week, let's say once a week, or once a month.
So every time, since you're using it only once a week and you want to shut it all the way down, all you really need to do is I would make sure that it's vacuum, like the chamber's vacuum sealed, so then the chamber's not exposed to the air while you're not using it.
Okay.
And then all you need to do is then close any of the precursors you're using, purge out the lines, and then just turn it off from the back.
Okay. So we need to purge off the lines. So we need to go back to when I'm trying to purge off the lines, I need to go back to the manual pulsing, and then do that, right? Okay.
Yep.
All right. That makes sense.
That's it.
The
It's pretty
process, we have to
straightforward.
close all the gases, right?
After the process, yes.
After process.
Nitrogen should be okay. It should be on.
Nitrogen should be on 24 hours, right?
Yeah, it could be on. As long as you don't have a leak.
If we are not working, then turn off the nitrogen, or?
Yeah, you can turn on the nitrogen. Yeah. But we need to basically
Make sure
create.
to always turn the nitrogen back on when you turn the system back on.
Yeah, the nitrogen has to be on. Okay, I think we're good.
Okay.
Yeah. Again, thank you so much, Clara. This is very helpful.
Yep.
Very helpful.
Yeah. We can set up another caller through email again.
Yes, absolutely.
Okay. Sounds good.
All right. Thank you.